For more information, please visit SGMAK Associates website.
Let's talk about exponential distribution. The exponential distribution has the density function given by f of x as lambda times e raised to the power minus lambda x. The random variable can take only non-negative values. The parameter lambda is a real positive constant. The exponential distribution is very closely related to the Poisson distribution. The Poisson distribution models the number of arrivals in the interval 0 to t. If you take an interval of length t, the Poisson distribution can model the arrival in that interval based on a constant arrival rate of lambda. The probability of k arrival during that interval is given by, that's the probability mass function for Poisson distribution, e raised to the power minus lambda t multiplied by lambda t raised to the power k divided by k factorial. K is the number of arrivals and it can take values 0, 1, 2, only take positive integer values including 0. Now, if I put k equals 0, then probability of no arrival is given by exponential minus lambda t. This also represents the probability of no arrival in the interval 0 to t. It also can be viewed as the probability that the first arrival happens beyond time t. So let's define another random variable, capital T, that represents the inter-arrival time. Then probability of no arrival during the interval 0 to small t can be written as probability capital T greater than t. That means inter-arrival time greater than t. No arrival took place during the interval length 0 to t. So then probability of zero arrival can be written as exponential minus lambda t. In terms of the CDF, if you write the CDF, then you can say f of t is the probability that arrival takes place within the time t. 1 minus f of t is the probability of no arrival. So 1 minus f of t can be written as exponential minus lambda t, or f of t can be written as 1 minus exponential minus lambda t. Now we are dealing with a continuous distribution. If we differentiate the CDF, then we get the probability density function. So if we differentiate with respect to time, the variable t here, we get f of t, which is the density function, as given as lambda times e raised to the power minus lambda t for t greater or equals 0. Now f of t equals lambda times e raised to the power minus lambda t is the well-known, is the PDF for the well-known exponential distribution. Every distribution has a unique density function. So what we get for the inter-arrival time follows the well-known exponential distribution. So you can say if the number of occurrences follows a Poisson distribution, then the time between occurrences follows an exponential distribution. The parameter lambda is the mean arrival rate for the Poisson distribution. Mean arrival rate for the Poisson distribution. And if we take the reciprocal of that, that represents the mean inter-arrival time for the corresponding exponential distribution. So if I take a lambda as 2 and my time unit is hour, then in a Poisson distribution we are saying an average arrival of 2 per hour. Then when you convert into exponential distribution, average inter-arrival time is 1/2 of an hour. On average, every half an hour, an arrival is taking place. That makes sense. Now, exponential distribution is a single parameter distribution. Once you define lambda, the distribution is completely defined. The mean of the distribution is given by 1 over lambda, and the variance is given by 1 over lambda square. So as you can see, as the mean increases, the variability increases with increase in mean. The random variable, as defined in this case, can take on non-negative values only. Now let's look at another example. Um, the problem says a manufacturer of electronic gadget offers a 1-year warranty. If the gadget fails during the warranty for any reason, it has to be replaced. The time to failure is well modeled by the exponential distribution with a parameter lambda is 0.25. So f of x is 0.25 times e raised to the power minus 0.25x, and x defines the time to failure, so can take only non-negative values measured in years here. Now we want to find out we have the following queries. First, what percentage of gadgets will fail within the warranty period? Number two, what percentage of gadgets will fail within the average life? Number three, the manufacturing cost of the unit is $50 and we make $70 profit. So you sell it at a price of $70 a unit. Manufacturing cost is 50 and we have a profit margin of $20 per unit. We want to find out what is the estimate of we want to estimate the effect of warranty on unit profit. Because of warranty issue, any failure before 1 year has to be replaced free of cost. So let's calculate these probabilities. So average life of this gadget is given by 1 over lambda. Lambda is 0.25. So the average life is 4 years. The CDF of x is given by 1 minus e raised to the power minus lambda x. So if I put x as 1, what is the probability that gadget will fail within the warranty period, which happens to be 1 year? It's given by 0.222 or 22.2%. And then if you want to find out what percentage will fail within the average time, average life, so we put instead of x, we put 1 over lambda, and we get 63.2%. So if a random variable follows exponential distribution, and if you're modeling failure time, then probability of failure within the average life is always 63.2% or 0.632. Profit per unit. How do you calculate profit per unit? We get a profit if the life exceeds 1 year warranty life, and if it fails, the profit is different. So you make $20 profit per unit if it clears the warranty period, but if it fails within the warranty period, then we lose $30 per unit, because first time when you sell, we get a revenue of 70. Out of that, there's a $50 of manufacturing cost. But if it fails, we got to replace another unit free of cost. So really, because of warranty, our profit is negative 30 per unit. So with that, you can compute the probability, and it comes out to be $8.90. So how much do we lose because of warranty? Is $20. If nothing fails within the warranty period, then every unit gives you $20 profit. But because of warranty, the expected profit drops down to we lose $8.90. So expected profit drops down to $11.10. Now we can use Excel function to estimate the different probabilities. So part A we can do using Excel, which is Excel has a statistical function called expon.distribution, and it has 3 input parameters. One is the value of x, the value of lambda, and the logical parameter true or false. So for the first one, we put expon distribution 1, 0.25, and true, because we want to find out the cumulative probability of failure within the first year, and that gives us 0.222. Lambda in this problem is 0.25. Now, so we get 22.2% or 0.22 as a failure probability within the warranty period. The expected profit per unit can be estimated as 20 times 1 minus f of 1. F is the cumulative distribution function. So 1 minus f of 1 is probability that is not failing within the warranty period, the $20 profit per unit, plus 70 minus 100 f of 1. And we can use.
Hi, we are posting materials online. If you have any doubts or any questions regarding the materials posted, feel free to get in touch with us through email. Provide your name, address, school name, your contact information. We also welcome if you provide comments so that things can be improved upon. We also appreciate if you provide any feedback. Okay, so let us know what do you think about the material posted. Okay, bye now.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.